Welcome to Through the Noise. I'm your host, Ernesto Glucksman. Hydrogen, the lightest element in the universe, so small that it can seep through iron pipes. It's too hard to compress it, hard to deliver it. Want to use it as transportation fuel? You can probably forget about that too. But it's super important for a lot of industrial processes that need high heat. The funny thing is, if you're using natural gas today, you can get hydrogen and you can take the carbon out of the process. My guest is CEO Tony Pan from Modern Electron. He has a new technology that can make hydrogen on site. Okay, Tony, man, thanks again. Good to see you again. I know we've been having a couple of conversations off mic and on mic. Thanks for coming back. Tony Pan, CEO of Modern Electron. This is a new initiative. This is like a new product line, new thing, sort of what you've been doing, right?
We've been working on hydrogen. I think it's about to be 3 years.
Okay.
But the company was started 6 years ago. So for us, it is the new kid on the block.
Okay. Because you have another product and solution that's more about converting, and just to go over, because you've been on the show before, but there might be some folks that haven't come across. You have this other product solution that converts through the use of heat, creates electricity and this is sort of like a product that can go inside furnaces and things like that. And that's more underway. That's been something you guys have been working towards commercialization and
yeah, that's right. I like to think that, well, we exist as a company to make energy both cleaner and cheaper, and particularly we're tasked with coming up with basically fundamental breakthroughs in applied science, applied engineering to create really novel new technologies. And frankly, you don't need to do that to decarbonize things that are easy to decarbonize, right? Like at this point, if you need clean electricity in the daytime, just install a solar panel. So there's no reason for people like us to work on that. We are working towards this idea of like decarbonizing heat. Heat is 50% of final energy demand. And so actually both our technologies and product lines are tackling different aspects of that.
Okay, so let's go into this realm of hydrogen, because it's a little bit confusing. There's been like a couple of booms and busts, I think, on the hydrogen world. The solution, this is going to be great. Look, it's almost like if you look at the end product of hydrogen, look, it burns, creates energy, and its only byproduct is some water. It's like, great, that's going to solve all our problems. The challenges, of course, is in distribution, transportation, storage, generation, all like getting it into that form on location, right? So can you walk us through just some of the basics on the sort of the hydrogen challenge, and then where does this new initiative sort of fit into that?
Yeah. So I love how you started, because honestly, as a scientist, I'm trained to be a skeptic, and there have been many hype cycles for hydrogen before. I think 15 years ago, the George W. Bush administration tried to do a very large push on hydrogen. Again, it has a lot of merits from an environmental perspective, right? Like you burn it, the waste product is water. Like how you can drink it, how awesome is that? But it didn't work. So you got to ask yourself, why didn't it work all the previous times? And that's a big question. Of course, there's complexity, but one of the biggest challenges with hydrogen, the elephant in the room, is that it is arguably one of the most challenging fuels you can imagine to transport and store. So it has all those magical properties of being clean. It produces good energy, but you can't get it from one place to the other easily. You can't get it to the customer. So how do you use it? So let me go one more layer deeper into the onion shell, okay? Because this comes down to the intrinsic properties of hydrogen. It's It's H2, right? It's a molecule. It's a very small and light molecule. The issue is one is energy density in terms of volume. So hydrogen only has 10% the volumetric energy density of gasoline. So you think about, let's say, a tank storing like your normal fuel that you use in a car versus now you have to store hydrogen. Now you have only 10% of your original energy. That's pretty bad.
You would need like 90% more space to equate the energy density of the gas tank to store. Like you got to put in a lot more gas to power at the same level, or the other way around, right? It's just, that doesn't seem efficient to me if everybody's used to having these cars with, 12 gallons of gas.
Yeah. In some cases, it becomes impossible, right? Like you literally don't have that much space in something that needs, let's say, a ship. If the volume of your ship is like, if your tanker is now just 50% fuel storage, you're not going to ship a lot of boxes.
That was so it's just forever. Like I saw that too. If 4% right now, cargo ships, 4% of storage is for the fuel. Which
is fine, right? That's perfectly fine.
Today. And that means 96% of the cargo ship can be stuff that you're going to move. But now if you were to switch to just hydrogen, it would take up nearly half the space of the ship just for the fuel. That's not going to, that's not happening, right? That's not going to happen.
Yeah.
So there's a ton of other
so there are
issues.
ways to solve this.
Okay.
Right. There are ways to solve this, but it's like picking your poison, right? One way to solve this is compress the hell out of it. But because hydrogen is so light, you essentially need extremely strong tanks. And therefore, in compressed hydrogen, when you compress the gas down, you end up with needing very, very thick and strong tanks. And so today in compressed hydrogen tanks, think like 5% of the weight of the tank is the hydrogen, 95% of the weight of the tank.
No, that's not going to work either. It's just a gigantic tank just to keep some compressed gas in there. Okay.
Yeah. Wow. So that's not, people do this, but it's very expensive.
Okay.
Or you could liquefy it. So when you turn something from a gas into a liquid, then it no longer, it's more condensed in volume and it doesn't exert pressure on the tank walls anymore. Unfortunately, hydrogen liquefies at negative 250 Celsius.
Okay.
That's like 20 plus degrees above absolute zero.
That's like
cryogenic
special labs to do this type of So that's crazy. That's not going to be, well, I don't know. Is it crazy? Is that doable? I don't know. It's
doable. It's just how much price do you want to pay? There's this famous International Energy Agency report that talks about the future of hydrogen. And make no mistake, people are investing massive amounts in hydrogen because for some sectors of the economy, there's no other way to decarbonize. Like you just can't electrify it. Hydrogen may be the most promising solutions, even with its warts. But it basically said in this report that, okay, you produce hydrogen, you generate it, and that has some cost. Now, if you want to move it any significant distance, triple the cost.
Okay.
Yeah.
That's rough.
So, that is rough. There is one last way that would actually work and would long-term be economical, which is to build dedicated pipelines for hydrogen. Like if you build a big tube, right, that made the right way, and just make this everywhere, then eventually you ship enough hydrogen through it, you amortize the cost of the upfront equipment to the hydrogen. Long-term, this can solve it. That's absolutely true. The issue is that this can't be like a normal pipeline. Hydrogen, like this is crazy. Hydrogen is such a small molecule, right? It's the lightest element in the universe. That if you put like iron pipe, a steel pipe, the hydrogen can literally pass through the iron's a big atom, right? The hydrogen can literally move through like the atom lattice
through the metal
iron pipe and leak out.
Wow.
Yeah, like it literally passes through what we consider a solid object.
Wow.
Yeah.
Wow.
So again, we know how to fix this. Like you use other materials and stuff like that, and you can make it work. The issue is that now you're talking about building a million-mile transportation and distribution network for hydrogen. Again, like we do have a network like that, the natural gas network. It took about a century to build, and there's probably $1 trillion of infrastructure of these pipelines that are laid down in the world over decades of time.
You
So
couldn't
eventually we
couldn't
can build
use
up
that, right? You couldn't
hydrogen,
reuse that
but
for with hydrogen
yeah,
because it would leak. It would leak
yeah,
through
you
that.
can't use the existing pipelines
Stuff.
for hydrogen. You've nailed it. Yes.
Okay, so it's not easy to compress, not easy to distribute. If we could do pipes, but that seems like just based on like just piping for natural gas and the investment that would be involved with that, that'd be perhaps too difficult, or maybe you can't find enough buyers of the hydrogen to justify the expense of the laying down the new pipe, right? Like that you need to find a bunch of people willing to buy
Yeah.
that to amortize the investment of the infrastructure. So why are we messing with hydrogen?
Because in the decarbonization fight, it doesn't seem we have a choice. So
Okay.
there are many things that we can electrify, such as the electricity grid. For the most part, you can put solar panels on your roof and produce a lot of clean energy for your home. And right, like the electricity can be used in everything from laptops, fans, air conditioners. And now with the electric vehicle revolution, we can also tackle light transport with electricity. However, there are many problems in energy and climate that are not so easy to electrify. So, for example, we use a lot of fossil fuels in the making of fertilizer. Like literally, this is one of my favorite quotes about how hard climate change is to tackle. Half the nitrogen in our bodies, like today, came from synthetic ammonia, synthetic fertilizer. That is made from natural gas, basically. And so if we stop using fossil fuels today, half of humanity will have to starve and die. We literally can't feed that many people.
If we were like, no more fossil fuels,
Yeah.
pull a whole ban on
Pull the
this
plug tomorrow, half of people will have to die
because we don't.
just from food alone.
Right.
So, and you can't electrify that, but you could use hydrogen as that's a chemical process, right? Like you're making chemicals. Hydrogen can be that chemical that facilitates the production of synthetic ammonia.
Okay.
Right? So that's just one example of why you need, like, let's say, a clean fuel instead of just an electron. There are other things such as making metals. Let's say you're making steel. There's both a chemical reaction that needs to happen when you make steel. For example, it's called reduction, but basically you need to remove oxygen from your messy iron ore so that it becomes a high concentration of just a metal atom. So you need something to take away the oxygen. So that's one of the many reactions that today is done with fossil fuels. And also you just need to get it to very high temperatures. So glass, cement, steel, iron, silicon, all involves a step in manufacturing where something is heated to
all
over
essential
1,000 Celsius.
Wow. Okay.
You are not going to be able to easily provide that with electricity. Today it's done by burning fuel. So that's why people are looking in the fight for decarbonization. They're looking for some fundamentally clean fuel that they can use, since they can't use an electron. And that's why, despite all the challenges with hydrogen we've discussed, there are still massive investments going in because we don't really know what else to do. And we're all working very hard to solve these challenges so that eventually, just like solar used to be 10 times more expensive, right, than coal-fired power plants. And a lot of innovation investments went in to bring it down, and now it works. We know there's all these other sectors of the economy we need to decarbonize. Electricity is not going to do it, but if we can get hydrogen a lot cheaper, a lot more accessible, and a lot more cleaner, then we can decarbonize all those sectors as well.
Okay. So walk me through this, because I got a feeling it involves some natural gas scenarios or some biofuel stuff, right? From your with this approach. Like what's the approach you guys have?
Yeah. So our approach is to convert natural gas into hydrogen without CO2 emissions.
Okay.
And basically our goal is to at least clean up one end of the natural gas pipe. In the USA, there are 3 million miles of gas transportation and distribution already available. I'm sure if you're like a person listening in and you live in the North, very high likelihood you have gas right there in your home. And this is also true for commercial buildings, industrial facilities. Gas is widely available and most people are already burning it and it's emitting CO2. Our whole point is we don't want to add the cost and decades of timescale to build any new infrastructure to transition to hydrogen. We're just going to take the natural gas that is already delivered to you on site and turn it into hydrogen right there. So if you can produce the hydrogen where the customer already is, you no longer need to deal with the grand challenge of moving hydrogen around. And so our technology does this without producing CO2, so we can make the hydrogen green.
Okay. So natural gas comes with a bunch of stuff, but it's really the fundamental molecule like carbon and hydrogen, and you're breaking it off before you burn it, burn the hydrogen, and then do something with the carbon, right?
Yeah, you're right. So natural gas, it's mostly methane, CH4. Okay. So it's the hydrogen's right there. You have 1 carbon atom and 4 hydrogen atoms. We're breaking it up so that it's solid carbon and the hydrogen gas is the useful output. And now because you've broken it up, when you burn it, you no longer emit the CO2.
Got it. And what does it look like when you have the CO2 in like this more solid in the solid state? It's just like a powder or something, or like
it looks like a powder. We like to joke that it's almost as if like we're taking chunks of coal out of natural gas and then putting it back into the ground, right? But it doesn't have the consistency of like the coal you're familiar with. This is more like pencil lead that is in powder form.
So this kind of addresses like, okay, if we're using natural gas and you're burning it, I can see, because your other product, you're using natural gas that you burn to run a water heater, and you're adding the thermionic process where you're sort of offloading electrons. Now you're looking at it in this other, more on the manufacturing side, where the natural gas is going to be burned to produce enough high heat to make steel or whatever in the plant. But you're putting a little step in there beforehand. We're sort of taking that carbon into solid form, letting then the plant use the hydrogen for their energy needs at that point. Is that about right?
Yeah, and you're catching on to like the big trick that we're doing. So the two technologies we have can work independently of each other. They don't need to be in the same product. You don't have to buy both. But really, the hydrogen piece is about cleaning up the fuel, so you have a clean fuel. And then the second piece, converting wasted energy, wasted heat into electricity, is about getting more efficiency out of the fuel you use. So if you think of it as like a chain, you first make the fuel cleaner, and then you use the fuel better. And both should save, right? Especially the second step, you should save money and reduce emissions at the same time.
Wow. So tell me, I know that you have, in terms of the stuff that you can talk about, but tell us about the new, this new initiative with the hydrogen technology. Like you're testing it. You won some funds, a grant from the Department of Commerce in Seattle. Is that right? In Washington State?
Washington State, yeah.
Okay.
So at this point, I can't actually in the biogas case, I can name names, but
okay.
In the application for biogas, we have partnered with a biogas company called Qualco, also in the Washington State area, and we were both funded an award to deploy this technology at their biogas facility. It's kind of cool. This biogas is coming from agricultural waste. literally cow poop in this scenario. And usually it's a very polluting thing. But now we're capturing our partner is capturing the pollutants, getting the biogas, and today the biogas is being used in a generator to produce electricity that is powering our neighborhood. We're going to go in and further clean it up by adding our box that takes the biogas in and then produces hydrogen out and also solid carbon. The hydrogen will go into the electricity generator and produce even cleaner electricity for the neighborhood. And then we're removing the solid carbon that would have originally become CO2 and emitted in the atmosphere, but now we're sequestering that. So this is actually what people call negative emissions, meaning that it is equivalent to removing CO2 from the atmosphere. Because what's really happening is the grass that the cow is eating is putting CO2 out of the atmosphere to make energy through photosynthesis. And then the cow eats the grass, the cow produces like biogas. And originally
bacteria in the cow's gut, right, does that eating processing of the cow. Yeah.
They're capturing originally, if you burned it turns back into CO2 and you complete the cycle, right? So it's net zero. But now if we take that biogas and we remove the solid carbon, then the CO2 doesn't go back into the atmosphere. So it's as if you're removing CO2 from the atmosphere, which is like very important. Unfortunately, this is a reflection of how bad things are in climate change. But even in the Paris Agreement itself, it's like there's like step one, reduce emissions, and step two is remove emissions from the atmosphere, because people already admit that we're not going to make it in time. We've already put so much CO2 in the atmosphere that in some sense, it's already too late. So to fully combat climate change, we eventually need to get to a step where we need to remove CO2 that we've originally put into the atmosphere, right? We need to remove CO2 in the atmosphere and put it somehow back into the ground. This is one way of doing so.
This is what, right? Because just to restate this part of it, the biogas capturing biogases. The grass used carbon in the atmosphere to grow. The cow then eats the grass. Then they were burning it to generate the electricity for the town over and release that CO2. It's net even. It's not like, because the grass used that CO2, it just went through the process and got expelled. But you're going to come in there with this process and you're going to capture that into solid form, the CO2. And so then you're actually extracting the CO2 out of this process. Now becomes a negative process towards extraction of CO2 out of the air. Right now, to what scale or whatever, it doesn't matter. The key is like this process didn't even exist perhaps 20, 30 years ago, right? They weren't even doing this. They were just, I don't know, using the cow manure and putting that back as fertilizer into the fields, which sounded like that's kind of a problem for other reasons, pollution into streams and things like that. So this is fascinating that they're able to actually get energy out of it. And you're able to take the carbon out of that whole process. What do you do with the carbon powder? Dig up a hole, stuff it in there, put it back in the ground?
That's a phenomenal question. And so there's two things you can do.
Okay.
One is, remember I mentioned this is like pencil lead. It's also called carbon black. It has economic uses. So for example, carbon black is used in everything from making tires. That's why your tires look black. Making asphalt, high qualities of carbon black, graphitic carbon is used to make battery electrodes. So the first step as you deploy this is to collect all this solid carbon and then just sell it. So it's used to make goods, right? That's probably the best economic use and also part of the circular economy. You want to make sure you're using all parts. Now, people are also looking into using carbon for more novel applications, such as mixing it into concrete. Concrete is a very big emitter of CO2, but if you can replace some of that concrete with solid carbon, this is earlier stage, but it seems that you can make concrete that is harder and more robust. So there are more futuristic applications like that. People are also using this to make carbon fiber, etc. Last but not least, though, I'm pretty serious about the notion of putting coal back into the ground. Uh, this is both attractive in terms of just permanently removing these emissions, but also, frankly, it's necessary at a larger scale. So we use so much natural gas as a civilization that if we use modern electrons technology to decarbonize most of its end use applications, we will be producing so much solid carbon that the current size of the carbon black market cannot use it all. So you will have to put the carbon into the ground. The cool thing is that we're not talking about making a dedicated mine and then having to put it back in the ground. It turns out that if you put solid carbon into like a landfill, so if you just put it in the trash and it goes into landfill, landfills are a low oxygen environment. This has to do with some of the biological processes that go with decomposition that happens in landfill. But the point is landfills are low oxygen, which means that solid carbon that you just dump in a landfill is going to remain stable for hundreds of years, at least hundreds of years. But we don't have the data for thousands of years. But basically, it's going to be stable and secure there and not turn back into CO2. It's not going to slowly oxidize and rust away. So it's actually, there's some straightforward methods of just disposing of the solid carbon.
Oh my God. Tony, this is phenomenal. What does the footprint look like for this? I mean, what can you tell us without, I guess, disclosing any like trade secrets or something that you're working on? Like, what is the footprint of the machinery? How does this sort of fit into that biofuel facility? Generation.
The nice thing about our technology is that it's scalable. This is like a common theme for our company. We are very focused on how to make distributed generation work, distributed generation of electricity, distributed generation of hydrogen. So we work on things that work on the small scale. And so the smallest scale that works in our lab right now is literally like the size of a person. It will come up to my shoulder. And today in the lab, it already converts over 90% of the gas coming in into hydrogen. So we'll get that efficiency higher and higher, but it already works. And so it really depends on where you're going to deploy, right? So we'll build larger generations of this as more the size of a shipping container, but it really depends on how much hydrogen the customer wants. If you are let's say you're a hospital building and we have letters of intent from hospitals. Hospitals use a lot of natural gas because they need to make steam, and you can't do that with to sterilize everything. And again, like you can make some heat with an electric heat pump, but not steam. And so that's why they need to find a different way to decarbonize their natural gas use. That's why they're interested in hydrogen. But hospitals are pretty large, so for a hospital, this thing will be more the size of like a shipping container to produce all the hydrogen that they would need to replace the natural gas that they're using.
How long does the process take when sort of like pumping in the natural gas? Then I'm assuming there's some like electricity thing. It's always with you guys, it's always electricity involved. Like what's that process like?
So it's pretty much like you're as the gas goes in, hydrogen is coming out, it reaches a steady state operation. And actually, we're primarily using heat as the energy source instead of electricity to break the stage 4 molecule into carbon and hydrogen because heat is a lot cheaper.
Okay.
There is actually a lot of work. I'd be remiss not to mention our competitors. There is a lot of work in also producing hydrogen from a process called electrolysis. And that is using electricity to break water into basically hydrogen and oxygen. That also works. And in some circumstances, that is a very good way to produce clean hydrogen because you source your clean electricity and then you use electrolysis to produce your hydrogen. The issue is that electricity in many circumstances tend to be more expensive than other fuel sources. So it depends on your situation as a customer. If you have access to very cheap renewable electricity, you might actually be better off. You're better off using electrolysis. Don't come to us.
Okay.
For many places, especially in many commercial buildings, many industrial sites, right? Like electricity is not just the cost of the solar panel, it's the cost of transmission and distribution. And I think as a homeowner, you're probably familiar with this, but electricity per kilowatt hour ends up being usually 3 to 5 times more expensive than gas and heat.
Mm. Yeah, which then makes it very difficult to be like, hey, I want to be more socially, environmentally conscious about this stuff. I want to use more electricity, but it's just so much cheaper with the natural gas stuff.
Right.
But then here comes Modern Electron with the solution on how to actually make this into a net negative carbon sink tool.
Right.
If you're gonna use natural gas to begin with. Wow. How did you come across this process? I guess we're using heat. So you're using some of the natural gas to generate the heat to then do the separation, right? You're cooking it in something. Okay. How did you guys come across this technology? Like, when did you start thinking like we can see if we can make this commercially viable?
Yeah. Okay. So you're gonna get exclusive. I'm eventually I'll find a way to delete this video from the internet and tell some magical story to reporters about how I knew hydrogen was the way of the future in some elementary school story, right? But what actually happened, I think that this will be fun for like actual audience to understand how innovation works, is we were looking at different ways of producing high temperature heat for our first product. Just one of the 100 like engineering ideas that you do as part of being a deep tech company. We have a lot of phenomenal scientists and engineers. I think we have 20 PhDs in the company. They're constantly inventing. And so this is one of the many ideas that we came up with to actually make a high temperature heat source for our first technology. Our first technology converts heat into electricity. And the hotter it is, the more efficient it is. So we came up with a bunch of different technologies to produce a high temperature flame. And one thing you can do to produce a high temperature flame is burning hydrogen. Hydrogen burns hotter than most other fuel sources.
Okay. Even natural gas.
Yeah, even natural gas.
Okay. I didn't know that.
Now, that was not the most effective way of us increasing the temperature and increasing efficiency for our first technology and product. So that was one of the many brainstorm items that was put into a box.
Oh, you stumbled across it. You're like, okay, that kind of worked for what we were trying. I don't know. We'll put that idea in the corner somewhere.
Right? Like this brainstorms. You always come up with like dozens of ideas and eventually you pick one or two. And this was actually one of the ideas that was left out because for the first product, that was not the number one thing you would do. Then, this was years ago, okay? As we were exploring applications of the first technology, we were deep into discussions with industry, right? And then this was years ago in Europe. And then people started asking us, but does your first technology work with hydrogen? And we're like, of course it does. It's a direct heat into electricity converter. It doesn't matter what fuel you use. We will be able to produce bonus electricity out of it. But we started hearing this from enough people. And this is before you saw hydrogen on the news. Now I think everybody knows there is a lot of investment in hydrogen. But years ago, it was a little bit talked about in like the deep energy circles, but not in popular consciousness. But that's how we learned about all of this. We learned that people were already building like hydrogen boilers. And so we realized, wait, people just want the hydrogen, right?
Right, because they're asking you, does it work with hydrogen? Because we want hydrogen, because we need hydrogen for whatever our industrial process is, right?
Yeah. And the funny thing is, like, they admitted they didn't have good sources of hydrogen. They didn't know how they were going to get hydrogen on site, but they were pretty convinced that eventually they would need to switch to hydrogen. So we realized people just wanted the hydrogen, and we had this unique idea for producing hydrogen. So again, this is years ago, but eventually, I think now it's publicly known Bill Gates is one of our investors. And so we in one of our regular checkup meetings with Bill, we said, okay, check this out. Like, we're pretty convinced people need hydrogen. We have this idea for it. What do you want us to do with it? And Bill, being the visionary that he is, he's like, okay, here's some extra money. Go and figure out if this has legs. This was the start of the journey. And then, of course, it worked, it got bigger, and then we raised even more money from it. and went through the maturation process. But that was the actual story of how we
Tony, it's amazing because there are a bunch of people looking at all the challenges with hydrogen, storing it cryogenically, transporting it, it leaks, and they're still going down the path of like, yeah, this is going to be the future. Somehow we'll solve this. And you kind of like fell into this because you were sort of experimenting on how to generate some high heat for the first product development, that you suddenly realized, oh, all these people just want hydrogen and they are already burning other stuff, natural gas. You might be able to do that. And then we have the leftover carbon, which probably contributes to carbon credit, some kind of carbon credit opportunities there, right?
Yeah. I put all those things in a general realm of, fortunately now there is an economic incentive in many countries to decarbonize. And I will say that is the one thing, like, I shouldn't make this sound like the best thing since apple pie, right? Like, there is really no reason to use hydrogen in a lot of circumstances unless you care about decarbonization. It goes to my earlier points of like hydrogen in many circumstances in its intrinsic properties is sort of like an inferior fuel to regular gasoline, natural gas, right? Because it has all these annoying properties, low energy density and so forth. So, Tesla,
Elon Musk came out being critical about Toyota's like gun-ho approach to like using hydrogen fuel cells and hydrogen, because it's just, I think he looked at that process like it's just too convoluted. It's just too much of a, Gordian knot to figure out how to actually get this, efficient enough that you can transport and so forth. But in any case, that's not the world you're in. You're really just like, well, people are using natural gas for all kinds of applications. It's happening on location, right? You're not it's being transported as natural gas. And then on that location, you could convert that into hydrogen for them. And you're left over with carbon. And if there's a carbon market for this, you're in the game. You have a solution here that can happen. Do the numbers really add up? Or are you still not sure? Or have you walked through that project with the current? I mean, I guess you have to do the number planning, the math, the math for where's this initiative that you're doing with the Washington State and Qualcomm? Sorry, just too many things in that question. Yeah.
It's actually pretty cool because it's also going to be the farm itself is on what is called the Tulalip tribe. So it's a reservation, and so this is a way to actually provide new technology and clean fuel to traditionally disadvantaged communities. So we think that's pretty cool. So that's not the actual only project, but the other ones are. There's sort of a reason, you probably know this is why we thought those are the coolest one to announce. But we have orders from utilities. Like if you think about, if you're a gas utility, right? Today, the USA ships more energy through the gas grid than the electricity grid. That's how important natural gas is. But if you're a utility and you're getting gas to customers, you're very nervous. Gas is a fossil fuel, it's emitting CO2. And so they need to find a way for them to be parts of the clean future. But like they have all these, again, in the USA, it's hundreds of billions. In the worldwide, it'd be trillions. All this infrastructure in the ground, that's what they're good at. Can they use the existing infrastructure to decarbonize? And we offer them a solution. So yeah, we already have orders from gas utilities. We also have investments from industrials. So remember when I said all these different materials, like to make metals, you need to use a lot of fossil fuel and you can't electrify that. So yeah, like they're also interested in hydrogen and they've invested. So there's a lot of applications where this is going into.
And when you're discussing this with these potential customers, you're going through you're doing the math, like they're going to invest, capital investment's going to go into creating the space, for the machine to be in, the connections, all that there has to be a return for that. Does the offset carbon in the carbon market, is that get calculated into the cost of the thing? They're using those carbon credits. It's part of that process, that calculation, right?
basically. Sometimes it's explicit and sometimes it's implicit,
Okay.
because the rules you expect from the government, sometimes it's going to be an explicit price, right? That like CO2 is taxed at yada, 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 or you're going to get credit if you don't emit a CO2. And so that's a direct economic value. That's one version of the calculation. But frankly, some of these rules are just, you have to decarbonize by 20% in 2030, 30% by 2035, and so forth, or else you're not allowed to operate. And so there's also implicit value in that, right? And so they just know they have to do this.
Right. And a lot of these energy, especially these energy companies, have made big proclamations of just how much they're going to decarbonize by certain dates. So presumably they've done the math because they see the path forward that they can do it, but they're probably looking for other quicker ways at the end use of their product lines, of the transportation. This is why you're getting calls for this type of product. Right?
Yeah. And I want to be very clear, right? Again, trained as a scientist, the intellectually honest answer is that, like, if there was no CO2 price or tax or incentive, hydrogen is going to be more expensive to use than the fossil fuel. You're adding extra equipment and you're removing the carbon, which initially had energy value, right? So with our process, frankly, if there was like no concern about CO2, you probably double the price of just using like the fuel for heat.
Straight right through into heat.
Yeah. And this comes down to the fact that CH4, if you look at that molecule, the carbon atom contains about 40+% of the energy content of CH4. So by not burning
you're getting more bang for your buck if you just burn the damn thing.
Yeah, you're exactly.
Of course, the problem with that is that society didn't realize that you have to price in the externality of climate change into that process. So that process has been subsidized by the lack of pricing in the actual true costs to the environment, to agriculture.
That's right. Like, and it's crazy.
Everything.
Like, we're dumping gigatons of CO2 into the atmosphere every year, right? 50 gigatons equivalent of CO2 in the atmosphere every year. And so the cool thing about our technology is when you look at some of these applications, and if you have to decarbonize now, this becomes, well, we're biased, but arguably the cheapest way you can do it. Because like removing the solid carbon, it's an extra step. But you know what's even harder? Trying to capture the CO2 and sequester it. CO2 is a gas.
Yes, I read an article recently. I forgot the name. Oh, it's Climate Works. They just created the largest carbon sequestration plant in the world, and it can only get about 0.0001 of the carbon out of the atmosphere. It's just so much more energy is going to be involved in trying to get that stuff out of the atmosphere than where you could just step in with the machine. Okay, you might double the cost in that process, but you actually can resell the carbon into something or store it on the ground. It's not been expelled into the air, right?
Yeah, you don't need to be a physicist for this to be intuitive, right? Like, you have an option of putting a solid carbon into the ground. I can see it, or I can scoop it, or which is why for the longest time the gas no one really cared about, because no one could see it, no one was seeing the impacts of it. It was diffused, right? Wow. Tony, I think you're on an awesome spot. This is another. I'm just going to keep coming to you guys and see what's the next product plan that you had on the back shelf that suddenly you realize, we could do something with this. Thank you, Tony. Thank you for walking us through this. I mean, can I ask you a couple of questions just off the cuff here? Like, when you're talking to people that are interested in this, they're already convinced, but is there some counterintuitive thing they have to understand, or what sort of, like, is there a spot in there where it's a little bit of a, wow, I didn't realize we could actually do this? That's a great question.
Or is it just selling itself? You're like, I can actually get you hydrogen and carbon in powder. And they're like, great, I want it.
Yeah, I think the mental inflection point is really about, wait, you're right. I already have hydrogen coming into my building all the time. It's just tied to a carbon atom. I'm like, we've heard people say that we're paying this vendor we don't really like $10 per kilogram for hydrogen that's shipped to us with all the challenges, right? Like we know they're making that hydrogen for maybe
from the same place,
$1.50 per kilogram, but they're selling it to us for 10. And some of that's margin, but a lot of that's because of the transport and logistics. But you're saying I can have some small box that just produces the hydrogen on site. I'm gonna be able to clean up, and it's actually gonna be cheaper. So I will say, like, we do have, if you're already using hydrogen and you're paying someone else for it, then we probably already have a direct economic incentive. Well, when I said earlier that like you need CO2 prices to make this sensible, I'm talking about if you're replacing a fossil fuel with hydrogen, then it doesn't you're doing it because of the CO2. If you already have to use hydrogen for other purposes, and remember I mentioned people already use hydrogen as a reactant for many chemicals or like industrial processes, so they have to use the hydrogen anyways. Then like we are a direct source of cheaper and more resilient hydrogen. It's cheaper because we save the cost of transportation and logistics. And it's also more resilient because if you imagine a bunch of hydrogen trucks being shipped, well, like any hurricanes, random events, car crashes, traffic jams, you're not getting your hydrogen today. And for some factories, if this is like big enough, they will have to not produce any goods for the next week.
This is kind of like the bottled water versus your tap, right? Like you're paying for the bottled water to be delivered. Maybe you could do something about putting a filter on your tap and using that, right?
That's right.
It's the same.
I've never thought of that one. I'm going to steal it for our marketing.
You're welcome to. Wow. This hey, Modern Electron, you guys seem to have a bright future. This is really cool. Tony, thank you so much. Let's keep in touch. And to the extent that you can tease us with something in the future or let us know, please swing by. Let's do this again. This is, I always learn stuff talking to you, Tony. Thanks.
No, it's always a pleasure. And again, like love your interview questions, that you just get things so quickly and see sort of you see the part where it's not obvious and you find the gem very quickly. It's always just
now you're just flattering me because now you're just flattering me because I'm in digital world. This is just new to me, so I'm just picking at the bits and pieces that I get. But thank you, Tony. I appreciate it. And I hope you guys listening to the show or watching it on YouTube, going to do more of these kinds of things. This is a really interesting world that's expanding into, the transition that we're all headed towards. So thank you, everybody. Take care. Bye-bye.
Okay. Bye.
Visit throughthenoise.us for more episodes and subscribe to our newsletter. This show is produced by Through the Noise Consulting, uniting external communications and internal IT functions to ensure data and privacy are protected while creating innovative communications platforms. Want to start your own podcast? We can help. Visit getthroughthenoise.com to learn more.